Alright, 710, the Idler Pulley, is the geometry with the crown, so we're going to have to do some interesting things with the arc. At the base, we have our center line. We have a 19 millimeter, no critical dimensions. But notice there's a 3 millimeter step, and it goes into a 3 millimeter radius. So, let's see, the 40 millimeters, that looks like it's at the base, and 36 millimeters at the top. Kind of hard to tell. It doesn't look like it comes up through the center. Oh, there is a step. So let's see, is there another dimension? Oh, there it is. So there is a critical dimension, the 28.5. So it has a bilateral, +5, minus 0. 12 millimeters, and I still don't see anything radius or diameter wise. So if the 40 comes up to the base, that's kind of an assumption. But it wouldn't put it too far out of line. So, all right, 143 on the diameter, 50 overall, and 73 to the step, 19. So, you know, anywhere you need to identify chain dimensions, 73 plus 19, that kind of becomes a little more important to make sure that it doesn't get missed. All right, so our new metric part. I go to the top plane again. We're in a revolve, so it gets a center line, vertical, infinite length, and goes to the point. I go back into the select, make sure everything took, and we'll do the first step, a little relief, the back over, and an angle. Okay, so yeah, that would go to the bottom. So let's go ahead and put that one in too. And if I'm going to make that a radius, if I want to go ahead and include the arc instead of making a separate radius, I'll do the continuous arc. If we were going to make it a radius, I would just come out 3 millimeters and then continue back over to the right. But if I go to the starting point, get my continuous, that's not the direction that I want, but that is. All right, so just kind of going back to that start point, repicking it, letting it find that geometry. All right, so let's just work with this much. And so the first is 40, and then we have the 28.58, and so that would be the smaller number since we have a plus tolerance to work with. So we're going to go bilateral and 0.00, or not 0.005, we're in metric, 0.05, and let it include the tolerance. All right, so we'll mark for drawing, and then this is going to come on over. So smart dimension, radius of 3, and then that, because we have that 90-degree arc, center is at the vertical and horizontal of the 2 points. Then the height will be 3. Let's bring it back over for the 19. Oh, maybe, yeah, 19 diameter, 20 on the step. Was trying to reverse those two numbers, and then 73 from the step to the end. So that puts us out at 93 overall. All right, so 36 millimeters at the top diameter. And we'll go ahead and bring that one down a little ways. Oh, we said we're going to stay with the 40. Since I haven't seen another dimension somewhere, so we'll pick the 2 endpoints, and those can be vertical. And there's enough there. Just making sure it's not intersecting into the geometry. Up and over and back. Alright, and the second inference line was trying to be parallel to the line we just created. Alright, so the web goes to 12 millimeter. The inside dimension is 105. And the outside dimension goes to 114. All right, and then the overall, no, I guess that's not really an overall height. Let's go ahead and finish out drawing the geometry. So this needs to come over, and then we'll connect the last two. Alright, so from what I can tell on the drawing, we have 8 millimeters for the step, and then from the bottom, well, we have 50 millimeters. Alright, and the very far outside then is the 143. Okay. So that geometry is looking good. Just a quick check, make sure I didn't miss anything. Features, Revolve base. And we'll go ahead and accept. Alright, so I did not include the crown. Alright, so we're given a radius of 250 millimeters from the point. The 21, all right, to the center. So what does that actually measure out at would be the question. So I need a number from here to here, and if that well, that comes up 38. Just thinking if it was 42, that would be center. That'd be nice and convenient. But we're dealing with, 50 minus 12, 38. All right, so we've got to shift that that arc just a little bit. So that's an interesting geometry. It doesn't go past the 143. So we're going to be making or not 143. It doesn't go past the 114. Well, that brings up a good point. Is the 114 to the edge? Or is it to the peak of the crown? Well, from that it looks like it's to the edge, so we'll actually be building out a little ways. Alright, so that would be one we'd want to mark for clarification, but for our purposes that will get it. So on the right plane, or the top plane, but we haven't used the right plane very much, so I'm going to find those points, and then we have we've been using mostly tangent arc, occasionally a center point. We're going to use a 3-point arc this time, which says pick the start, pick the end, and then you still have a dash 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 line, so you're going to drag it until it looks like it's where it's supposed to be. Alright, so there's the center point. And that was 21 from this top edge, and that's kind of scary that it went right there, and no decimal places. And then we need a radius of, didn't like that one, so alright, so let's leave that driven for now. Yeah, it's still able to move, so that's interesting. It needs to be connected at the points. So we're able to make it smaller. So I'm going to switch the 21 to driven. And then we'll come back over to the radius and uncheck the driven. So 250. So that narrows it up. All right, and the arc's still at 21, so it figured that out. All right, so I'm good with that that geometry. And I can turn on the temporary axes. It should, when we go into the feature, revolve. Nope, we're not cutting out the material. We're revolving the boss base. The axis of revolution, well, should be able to pick the inside. No, it's looking for an axis. Then we'll have to go to temporary. Pick the temporary axis. There it goes. 360 degrees. Let it build out. So there's just a slight arc, and we'll see it bulge just a little bit. Alright, so I could have included that in the first sketch, but first sketch was getting complicated enough. Adding on that little piece of geometry, and we may go back in on a redesign and decide that it doesn't need the crown. It's easy enough to suppress the arc out and modify the geometry that way. Alright, so we'll go into isometric view. We have a radius of 2 in the outside corners and 6 on the inside. So that being the case, here's an instance where I can select the face, go into the fillet, and it's going to be 2 millimeters, and we'll accept. And so both edges, the 2 edges associated with the face, get the fillet. And then on the inside, that goes to 6 millimeters. And same thing, we'll have 6 millimeters on the interior ring and 6 millimeters on the exterior. Alright, so not that the geometry is complicated, it just has to be analyzed and deciphered and made to work.